Okay, in Chapter 4, we are going to be dealing with quadratic functions and quadratic equations, and that'll be the general theme for the entire chapter. The section that we're going to look at today, and even the next section 4.2, is going to deal with graphing the quadratic functions. We're going to look at one form of the quadratic today, and the next lesson will be in a different form. Alright, so there's several notes here that you'll need to write down before we get started with some examples. So as it states here, a parabola is the graph of a quadratic function. Now you're all used to, for instance, like graphing lines. A line is referred to as a linear function. So when you have the shape of what's called a parabola, that's that bowl-shaped graph that you have dealt with a little bit in the past, and probably in Algebra 1. Those are called quadratic functions. Now there's two forms that they can be written in. The first one that you have here, f of x is equal to ax squared plus bx plus c, or you have the second form that I have listed. Now I've highlighted the x squared because that's what lets you know that you're dealing with a quadratic function, is because the largest exponent that you have is to the second power. You change that, then you're dealing with a different type of function. So you've got your square here. Now this looks different, but you notice you still have a square here. So this will be the two forms that we're going to look at over the next couple of lessons. Actually, this is the one we're going to talk about in detail today. Next lesson we'll come back to this one. Okay, so like I said, there's several sheets here of just some notes that you'll need to write down. Alright, so what I have drawn here first is two parabolas. So if you didn't know what I was talking about a while ago when I said they're the bowl-shaped graph, this is what the graph of all of your quadratic functions will look like. They'll either turn up or they'll turn down. Now, a couple of parts that you have to a parabola. First of all, you have what's called the vertex. Of course, this, if your parabola opens up, your vertex is located at the very bottom. If your parabola turns down, then your vertex is located at the very top. Then we also have what's called an axis of symmetry. It's an imaginary vertical line, and that would be, it's just dotted in, but if you notice in each of these situations, this vertical line goes down through the vertex. So axis of symmetry always goes through the vertex in both situations. What that does is it actually cuts your parabola in half, so like the left side and the right side would always be mirror images of each other, and that's going to help us in graphing these in a little bit. Okay, so as I mentioned, this is the form that we're going to be looking at and concentrating on today, and this is what they call vertex form. It's referred to as vertex form because you can easily look at it and tell what the vertex is without having to do any work. So the h and the k, the h is always going to be the number that you have inside the parentheses here, and the k is always going to be the number that's, of course it could be subtracted if it's a negative number, but it's always going to be here at the end. So this will be, the number you have in here is used as the x coordinate for your vertex. This number is used as the y coordinate. Now I've made a note here where I've said to change the sign of h. That's because when it's written in this vertex form, this is written with a minus sign. So whatever number you have here, when you go to identify it here as part of the vertex, just change the sign of it. So you'll see what I'm talking about when we actually get some numbers going here. But the k, you've got a plus sign in front of the k, so you wouldn't actually bother changing the sign in that situation. Okay, next. Here is what's referred to as the parent function. This is just your basic graph for y equal x squared. So it is your quadratic because it's the second power, but this would be like your beginning function, your basic quadratic function, and then we're going to use this to help us do some other things in a little bit. Now I just created a table here with 5 points. You could put more points in here if you chose to, but like for instance, if I plugged in -2, -2 squared gives me the 4, Negative 1 squared gives me 1. Of course, 0 squared is 0. And then 1 squared is 1. And then 2 squared is 4. I mean, you could expand on that if you wanted. And I've just plotted those 5 points. When we actually go to do the work on these in just a little bit, the 3 points that I have down here at the bottom will be the 3 that I'm going to use. We don't have to use all 5 of them. We're going to use these 3. Now, we're going to graph these based on transformations. And I do believe you've probably already covered these transformation rules earlier when you did absolute value functions. So they're exactly the same rules. Of course, things will look a little bit different because we're going to have things, the x to the second power instead of having an absolute value of x. All right, but walking you through each one of these, if you have your quadratic function, your x squared, and then after that you have a number added. K is just representing a number. So if you have a number that's added, then that means that your graph is going to shift up this number of units. So like if this is plus 5, it's going to shift up 5. Okay, so instead of adding a number after your x squared, if it's subtracted, that just means that your function is going to shift down that number of units. Okay, the second part that I have over here, you notice has to do with your graph shifting left or shifting right. But look at the location of the plus k and the minus k. So like over here, the plus k and the minus k is after the x squared. Here, the plus k and the minus k is actually included in the part that's being squared. I just commonly refer to this as being inside the function. This I just normally refer to as just being tacked on to the end. Now minus in this case would mean it shifts to the right, and plus means that it shifts to the left. Okay, next, in this square, what you have, or this section, you have reflections. You can reflect your graph about the x-axis and also about the y-axis. That's going to be based on where you have a negative sign located. If your negative is in front of your x squared, then it's reflected about the x-axis. If your negative is inside the part that's being squared, just like over here I referred to these being inside, if the negative is inside, then you're going to have a reflection about the y-axis. You don't come across this situation much with parabolas because a lot of the times when you reflect a parabola about the y-axis, it doesn't look any different. So most of what we're going to deal with right now is just going to be the x-axis reflection. Okay, last, what you have is referred to as a vertical stretch or a vertical compression. Now, the textbook that these notes come from use compression. Some textbooks refer to this as a shrink, so that might be something that you're more accustomed to hearing. So a vertical stretch or a vertical shrink or a vertical compression. Okay, this is going to occur when you have a number multiplied times x squared. So 2 times x squared, 1/2 times x squared. Now when we go to work the problems, we're going to work them all the same way. But if this number a is a number that's bigger than 1, then it's called a stretch. If this number a is a number that's between 0 and 1, then it's referred to as a compression or a shrink. And just go ahead and write this little note down. I'll actually explain what that means when we start working some problems in a little bit. Now when we start doing the transformations, there is a certain order that you're supposed to do the transformations in. One thing that you might notice as you're working some of the problems is some of them you can do in whatever order you want to and you will get the correct answer. But then sometimes if you don't do it in the correct order, you won't get the correct answer. It just has to do with what combination of the transformations that you have mixed together as to, if you really have to stick to the order. So to be safe, just always stick to doing it in this order. Okay, so as I go through my examples, I'll be referring to doing the horizontal shift first. Of course, this would be left or right. Of course, this is the stretch, the compression. reflection would mean like x-axis, y-axis reflection, and vertical shift would be up or down. So we'll go through and you'll hear me refer to this order each time. Okay, so like I said, there's several notes here on this first part, so the next part of the video we'll actually start working some examples.